of students think chapter 7 is going to be the hardest chapter, okay? And it's because of all the formulas. 7.1 is fundamental identities. So all of these formulas that you see are kind of like building blocks, things that we will use to figure out problems and answers and different other equations and things like that. So if you want to pause it so you can get all these formulas down, do so now. We're going to start with example 1. And example 1, you've actually seen this kind of problem before. All right, now I'm going to show you a different way of doing it. The last time, we did this problem, we drew a picture. And so, when you see tangent theta equals -5/3 and theta is in quadrant 2, what we did was we drew a picture in quadrant 2. I don't know if you remember this. Chapter 5 we did some, and chapter 6 I believe we did some again. But we draw an angle in the second quadrant, okay? And since we know tangent is y over x, we could fill in the y side of the triangle and the x side of the triangle. And then we could do Pythagorean's theorem to find the hypotenuse, and we call that r. Then we have this formula. It was 5 squared plus -3 squared. That's 25 plus 9. We've got the square root of 34 there. That hypotenuse is the square root of 34. So when part A says they want to find secant, okay, we know secant is 1 over cosine theta, or the reciprocal of cosine theta. And you should be able to see in this picture that cosine theta is -3 over the square root of 34. Okay? It's x over r. And so if secant is that reciprocal, then take that reciprocal, you're going to get -square root of 34 over 3. That would be the answer. Okay? That would be what secant theta equals. And we've already done this. Okay? We just did it geometrically by drawing a picture. I hope you guys remember doing it. Okay? Now, that being said, that's not what this chapter is about. And so we're really not supposed to be drawing that picture. We're supposed to be using those identities. Okay? And so, in order to use those identities, you're looking at what you know and what you want to know. If I know tangent and want to know secant, we've got to go back and look at those formulas and try to find a formula that has those two identities in it, or has those two functions in it. And so, see how this formula right here, tangent squared theta plus 1 equals secant squared theta? We are supposed to use that formula. Tangent squared theta plus 1 equals secant squared theta. We're supposed to use this formula, not draw a picture. We're not supposed to draw a picture. We're supposed to use this formula. So tangent squared theta just means take this and square it. Okay? We want to square this thing. So if you square this, you should be able to do that in your head. -5/3, if I squared that, would be 25 over 9. So 25/9 plus 1 equals secant squared theta. Now we're adding fractions, so to add fractions you would want a common denominator. So let's change that 1 into 9/9. So we have 25/9 plus 9/9 is 34/9. So 34/9 equals secant squared theta. Now if I want to know what secant squared, if just secant theta is, I'm going to take the square root of both sides, right? In order to solve this equation, in order to get rid of that squared, I do the square root. Okay, now the tricky part is, technically it's a plus or minus root. Okay, it's a plus or minus root. Remember how we always have the what and the where? The plus or minus is talking about where. So we have secant theta is going to equal plus or minus square root of 34 over 3, because that's the square root of 9, right? Okay, but at this step, this last step, you would say, oh, wait a minute, we're in the second quadrant, quadrant 2, and what do we know about secant? Remember, secant goes with cosine. What do we know about cosine and secant in the second quadrant? It's negative, okay? So we would know that secant theta is negative square root of 34 over 3. So that's kind of a lot of work for something that we already knew how to do by drawing a picture. But that's what this chapter is about. We're solving the same problem, but we're doing it algebraically instead of geometrically. In part B of this question, we want to find the value of sine theta. Okay, and again, if you look at the picture up at the top, we should be able to see sine theta because sine is y over r. If you just rationalize that, that's your answer. Okay, we can tell by the picture really quickly that the answer is going to be this. And now again, it kind of stinks because we're not really supposed to be using the picture. All right, we're supposed to be using formulas. We're supposed to be using identities. And so look at what you want to know. We want to know sine theta. Look at what you already know. We know tangent theta. But we also know secant theta because we just found it in the last part. And by the way, we know cosine theta. I mean, we know the reciprocal of secant. So we actually know kind of a lot of stuff. And so we have options here. There are several different formulas that you could use. And so we look for one with some stuff that we know, okay? Look back at your identities, and probably the one that I like to use the most is this one, okay? Sine squared theta plus cosine squared theta equals 1. This is one that you need to memorize. It's the Pythagorean identity. It's the most important one, probably, the most common one, definitely. So what I want to use is sine squared theta plus cosine squared theta equals 1. This is one way of doing it. There are certainly other ways of doing it. But cosine squared, remember cosine is going to be the reciprocal of secant. So I'd have 3 over negative square root of 34 squared. That's the reciprocal of secant, but I'm going to end up squaring. And so I don't even need to rationalize that denominator when I flip it, because the square is going to make that go away. When I square that, I'm going to get 9 over 34. And so I'm looking at sine squared theta plus 9/34 equals 1. So in order to solve, you're just trying to undo operations, just like you've done since Algebra 1 class. So you're going to subtract this 9/34 over. But we're dealing with fractions here. So if you're going to deal with fractions, let's get a common denominator. Let's call that 1. Let's call that 34/34. Okay? And so 34/34 minus 9/34 is 25/34. So we're saying sine squared theta equals 25/34. And so the last step, if I want to get sine theta, I'm going to have to get rid of that squared. I'm going to have to do the square root. Now, the most common mistake that people will make is they forget it's plus or minus, actually. Okay, it's a plus or minus square root there, because at this point, we haven't really considered what quadrant we're in. Okay, so you do a plus or minus square root of 34. That's going to give sine theta equals plus or minus 5 over the square root of 34. Now, in that step, you can go back and say, oh, yeah, but wait a minute, we're in the second quadrant, right? We're in the second quadrant, and what do we know about sine in the second quadrant? It's positive. So we know it's going to be the positive version. Let's just rationalize. And that's going to give us sine theta equals 5 times the square root of 34 over 34. Okay. Now, you might be asking yourself, why would we want to do all that work when we can just look up at the picture and get it a lot faster? Okay? We look at the picture and get that same answer a lot faster, and that's true. Okay? That's a tough question, but I guess the answer to that question, why do I have to do it this way, is just because we're trying to learn something. All right? We're trying to exercise our brains. We're trying to learn a new technique. We're trying to learn about these ideas. Okay? So this may not be the fastest way of getting that answer, but that's what we're going to do. So let's look at part C, cotangent of negative theta. Now, remember your negative angle identity. This is an odd function. Cotangent is odd, and when you've got an odd function, you're allowed to just pull that negative out. Okay? So negative cotangent theta. We're still in example 1, so we've still got all this. We've still got all the same given information. Okay? Remember how we knew tangent? At the very beginning, tangent was negative 5/3. Tangent was negative 5/3. Well, cotangent is just that reciprocal. Okay? Cotangent is just that reciprocal, so negative reciprocal, we'd have negative 3/5, or the opposite of negative 3/5 is positive 3/5. Cotangent negative theta equals 3/5. Example 2, and this is going to be a challenge, but we're expressing one function in terms, that's a spelling error, one function in terms of another. Express cosine in terms of tangent. Okay, cosine x in terms of tangent x. Now, think about what we're doing. If I said 3x plus 2y equals 6, and if I said express y in terms of x, okay, that means solve for y. All right, that means solve for y. And so you subtract the 3x over, and you divide by 2. I just expressed y in terms of x. Okay, basically they're saying solve for y. Here they're saying solve for cosine. Okay, solve for cosine x. So I know a lot of students just don't understand what that means. Express cosine x in terms of tangent x. I want cosine x equals blah 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 tangent x blah blah blah. Okay, that's what I'm looking for, right? So what we have to do is we have to find an equation that relates those two functions, all right? And so I think a lot of the times people want to use this one, and that's a great idea because it has a tangent in it and it has a cosine in it, but we've got this problem of having a sine in it. I don't have any information about sine. I don't want sine. It doesn't say write cosine in terms of tangent and sine. It just wants cosine in terms of tangent. So I'm not really allowed to have that sine in there at all. So we need to find another way of doing it. Okay? What we're going to have to do, tangent squared x plus 1 equals cosecant squared x. No, that's not right. It's secant squared x, isn't it? Secant squared x. Okay? Tangent squared x plus 1 equals secant squared x. Because we're going to be able to flip this secant. We know the reciprocal of secant is cosine. And so that's going to be our connection. All right? So let's start with that identity. And let's say, okay, secant is 1 over cosine. So we're going to say tangent squared x plus 1 equals 1 over cosine squared x. And then, there's a couple of ways of thinking about it. If you want to think about it as cross multiplication, go for it. Or if you want to think about flipping the equation, you don't want this cosine x on the bottom. Okay? So essentially we're flipping the thing. And it would say cosine squared x equals 1 over tangent squared x plus 1. Okay? If I cross multiply it, I'm trying to get the cosine squared x on the top. Okay? So you can think about cross multiplication, or you can think about flipping. Well, we got cosine squared x equals 1 over tangent squared x plus 1. Okay? Or maybe it would help if we wrote it backwards and said cosine squared x equals 1 over tangent squared x plus 1. At this point, we're almost there. Okay? We're almost there. We would just have to get rid of that square. And so we're going to get rid of that square by taking the square root. Take the square root. Now, one thing that a lot of people will forget is it's really a plus or minus. It's a plus or minus square root at that point. Okay? It's a plus or minus square root at that point. And if we knew what quadrant it was in, maybe then we could pick one. But since we don't, we can't. And we've got cosine x equals plus or minus. Square root of 1 is just 1. Square root of 1 is 1. And on the bottom, I would have the square root of tangent squared x plus 1. And, it would be nice if we were finished at that point. It looks like we're finished at that point. However, we know we can't end up with the square root on the bottom. Ever since algebra class, algebra 1 or algebra 2, whenever you did that, you're not allowed to end up with that square root on the bottom. And so we're going to rationalize, just like we always have. You multiply by that square root. Whole thing, tangent squared x plus 1, tangent squared x plus 1. And that's going to give us this big old mess. Okay? It's going to be plus or minus square root of tangent squared x plus 1 on the top. But then on the bottom, the square root goes away. Okay? What happens is if you've got square root of something times square root of something, it just ends up being that something. So on the bottom, we've got tangent squared x plus 1. And that's it. Cosine x equals plus or minus square root tangent squared x plus 1 all over tangent squared x plus 1. So again, think about what they asked me to do. They wanted me to write cosine in terms of tangent. That's what I did. I basically solved for cosine and rationalized the denominator. Example 3, we're writing tangent theta plus cotangent theta in terms of sine and cosine. Okay, sine theta and cosine theta. This is a very common trick that you'll use. It's a very common skill in order to try to simplify expressions. You'll just rewrite stuff using sine and cosine, and then things will start falling out a lot of times. Okay, so tangent theta plus cotangent theta, we want to write those in terms of sine and cosine. And so maybe you already have this memorized, but we know tangent theta is sine theta over cosine theta. And so we should just be able to do sine theta over cosine theta plus, and then we know cotangent theta is cosine over sine. So cosine theta over sine theta. Make sure you put your theta in there. If you don't, it's wrong. So that seems to be what they're asking me to do. Write tangent theta plus cotangent theta in terms of sine theta and cosine theta. I did it. Okay? But what we haven't done yet is simplify the expression. Usually they want you to combine fractions, or sometimes they don't want any fractions, but combine fractions. And so something we're going to have to do when we add fractions, if you were adding 1/3 plus 1/2, okay, 2/5, okay? You'd have to get a common denominator. When we're adding fractions, we're going to have to get a common denominator. And so that's what we're going to have to do on this fraction. Okay? Get a common denominator, and that shouldn't be the hardest thing in the world to do, because like this problem right here, if I had 1/3 plus 2/5, we would just make sure this one has 5, and we'd make sure this one has 3, and then we go. They just need, one of them needs a 5, and one of them needs a 3, and they need a 5 and a 3. So over here, if this fraction has a cosine, we need to make sure it has a sine. Okay? And so what we're going to do is we're going to multiply by sine theta over sine theta on that left side. But over there on the right side, this one has a sine theta, it's going to need a cosine theta. So multiply by cosine theta over cosine theta. So if you clean that up a little bit, sine theta times sine theta is sine squared theta over sine theta cosine theta. And cosine theta times cosine theta is cosine squared theta. And this one's over sine theta cosine theta. You have a common denominator now. And when you have a common denominator, you should be able to combine those two fractions into one. You know, imagine if you had 7/4 plus 3/4, you would know that you could combine that into 10/4. Okay? So we do the same thing. We just sine squared theta plus cosine squared theta, whatever that is all over that one denominator. Now, something hopefully at some point should pop out to you. Okay, that sine squared theta plus cosine squared theta is a very common formula that we'll see. Okay, go back and look at your identities. Sine squared theta plus cosine squared theta. Look, where have you seen that before? Is there a way to simplify sine squared theta plus cosine squared theta? What does sine squared theta plus cosine squared theta equal? 1, right? Sine squared theta plus cosine squared theta equals 1. That was that identity. And so what we have now is 1 over sine theta cosine theta. And so what they wanted me to do is they wanted me to write tangent theta plus cotangent theta in terms of sine and cosine. And we're going to have something like this.